To the audience, this is Sandro Francesco Tedde. He is, oh my goodness, now the title will be the difficult one actually. He's key expert research scientist at Siemens Healthineers, aka Siemens Healthcare. And today he will talk about, as you can read, Perovskites, the emergence of a new era for high-resolving and ultra-sensitive flat panel X-ray detectors. And with that, Sandro, the stage is yours.
Yeah, thank you, Christoph, for the introduction. And of course, thank you, Kasia, for inviting me to this very nice event. And thank you for attending this talk. I would like to dive a little bit into the X-ray detector world now, and in particular, this new wonderkind or kind child, which are perovskites, is a new material which we think that will be the beginning of a new era of high resolving and how ultra high sensitive X-ray detectors. But before starting with the details, why are we doing this? So Siemens Healthineers, of course, strive to enable healthcare providers in increasing value. So what we want to achieve is enabling better outcomes at lower cost for healthcare providers, but of course also for patients. And we are doing this in focusing more or less on 4 different ways. So we want to expand precision medicine. We want to transform how care is delivered. We want to improve patient experience. And of course, we want to digitalize healthcare. And the topic I will talk today is more or less, let's see, can you see my mouse? I hope so. It's extending precision medicine. So the X-ray detectors we're talking about today is expanding precision medicine. So flat panel X-ray detectors are basically the eyes of the system we sell to the customers. So here just some examples of radiography or angiography of mammography systems, and basically these systems are based always on an X-ray source. In this case, here is on the top part, and then there is a flat panel X-ray detector. In this case, embedded in the patient table. This is a classical radiography system. This is a more complicated angiography system. It's a kind of biplane system where we have 2 X-ray tubes, which are these 2, and we have the X-ray detectors, which are shown here. So it's possible to see the patient from 2 different angulations. And also in mammography system, we have a X-ray detector, and then we have the compression part, and the X-ray tube is on the top. So as you can see, we can only make images, of course, with the X-ray detectors. These are diagnostic or therapeutic images. Yeah, the technology behind X-ray detectors. So how it is possible, of course, to make images if you have a pixelated detector. So you need pixels, and usually in X pixel you have in principle a photodiode. So in this case we are just schematizing 3 pixels here, but of course you have millions in an X-ray detector. You have a photo detector and a transistor in each pixel, and the photo detector is of course detecting light. And where is the light coming? The light is coming from a scintillator, and the scintillator is basically converting X-ray into light, and the light is then going to be converted in the photodetectors. Usually it's amorphous silicon photodetectors. And this is called an indirect X-ray conversion, because you have a conversion from X-ray photons into light, and then from light into charges. The peculiarity of this detector is they have a really high sensitivity, so we can detect signals even in single X-ray photons. However, we have a relatively low resolution, and the reason is shown here. So the light is spread isotropically where in the point where the X-ray photon is absorbed. So basically, photons are going in the generation here are going over several pixels, and this is somehow degrading the potential resolution of this detector. So there is a second